All right, welcome. Today we're doing something a little different. We're going local. We're going to unlock the doors of a single college department to see what kind of universe-spanning research is happening inside. So what secrets can one physics department possibly hold? Well, let's dive in and find out. And here they are. This is the team, the faculty of the physics department at Raj Rishi College in Alwar, India. Now behind these friendly faces are minds tackling some of the biggest and, well, the smallest questions in the universe. And as you're about to see, their range is nothing short of incredible. You know, it's a question we don't really ask about our local colleges all that often. But the answers, they can be totally mind-blowing. As we're going to see, their work touches on everything from the vastness of space all the way down to the ground beneath our feet. Okay, so we're going to start big, and I mean really big. We're talking about the fundamental stuff that makes up the entire cosmos. Whoa, okay, that title is a lot, right? Don't let the jargon scare you off, though. What this paper really shows us is where their research starts, with the very building blocks of our universe. And this isn't just some abstract theory. No, this is like a window into the super extreme environments of distant stars and galaxies. So what even is plasma? Well, simply put, it's what happens when you heat a gas so much that its atoms literally break apart. Stars are made of it, lightning is made of it. It is, by far, the most common state of matter out there. So yeah, understanding how it behaves is kind of key to understanding the universe. And here's where it gets really cool. This paper looks at how these special waves, called solitons, move through plasma that also contains positrons. That's the antimatter version of an electron. Now, you can think of solitons as these super stable waves that can travel huge distances without falling apart. By modeling these extreme conditions, the researchers can figure out what's happening in actual cosmic places, like inside Saturn's magnetosphere. It's basically cosmic detective work. But as fascinating as all that is, the work at Raj Rishi College doesn't just stay out in space. In fact, in a pretty dramatic shift, their research comes right back down to Earth, literally. And this brings us to our second big area of focus. And honestly, this just shows the incredible range we're talking about with this department. From the physics of plasma to the physics of soil. I know, it sounds like a huge leap, but the same basic principles are at play. This paper looks into the electrical properties of soil, and specifically how those properties change depending on how much water is in it. It might not sound as flashy as pulsars, but believe me, its impact on our daily lives is enormous. The key thing they're looking at here is something called the dielectric constant. Just think of it like this. It's a number that tells you how well soil can hold on to an electric charge. And what's the one thing that changes that number the most? Yep, water. So why should we care? What's the point? Well, the applications here are incredibly practical. For farmers, this could lead to smart sensors that tell them exactly when and how much to water their fields. That saves a ton of resources and means bigger harvests. For environmental scientists, it's a game changer for monitoring soil health. It even helps improve the satellite tech we use to manage land from space. Okay, so we've seen cosmic physics, we've seen environmental science, but who are the actual people connecting these incredible and seemingly totally different worlds? Let's look at just one more field to bring it all together, superconductors. I mean, these are truly revolutionary materials. They can conduct electricity with absolutely zero energy loss. We're talking about things like hyper-efficient power grids, maglev trains, all sorts of next-gen tech. And the potential here is not being exaggerated. I mean, this quote from the paper's abstract says it all. This technology could change our civilization in the same way that electricity did. Wow. That is a powerful, powerful vision for the future. So who is the researcher with this kind of incredible foresight? Who's connecting fundamental physics to technology that could literally change the world? And here's the connection. The author of that visionary survey on superconductors is Professor Kamlesh Kumari. You can see her name right here on the paper and, yep, right here on the department's faculty list. But wait, the story doesn't end there. Professor Kumari's expertise isn't just stuck in one area. And this is what makes the work happening here so compelling. Hey, remember that paper on soil science? The one with massive implications for farming and the environment? Well, it turns out the lead author on that study is also Professor Kamlesh Kumari, from civilization-altering superconductors to the soil that feeds us. I mean, come on, that is an incredible display of scientific range. So let's just pull back for a second and look at the big picture. What does all of this really tell us?
What we're seeing is a department that's tackling science across its entire spectrum. You've got the fundamental laws of the cosmos, you've got the applied materials that are going to build our future, and you've got the environmental science that's going to sustain our planet. It is all connected.
And that brings us right back to them. It's such a powerful reminder that important groundbreaking research isn't just happening in a few famous high-tech labs. It's happening in colleges and universities all over the world, driven by passionate, curious people who are dedicated to expanding what we know. And that kind of leaves us with one last thought. We just got a little glimpse inside Raj Rishi College, but it makes you wonder, doesn't it? What about the college in your town? What new frontiers are they exploring? What world-changing science might be happening right now, just down the road from you?